Have you ever pondered about the possibility of traveling through time, journeying to the past to witness history or venturing into the future to see what's yet to come? Time travel, a concept that has captivated the human imagination for centuries, is a topic that is as fascinating as it is complex. It's a notion that has been explored in countless works of fiction, yet remains elusive in the realm of reality. But what if I told you that we are all time travelers? Intriguing, isn't it? Well, let's dive a little deeper into this mystery. You see, time is not just a measure of seconds, minutes, and hours. It's a dimension, much like the three dimensions of space we're familiar with: length, width, and height. And just as we move through space, we are constantly moving through time. But here's the catch. We are always moving forward, never backward. This forward movement through time is a consequence of our existence within a four-dimensional universe, where everything moves at the speed of light through space-time. This journey through time is an unceasing march, a relentless voyage into the future. And while we can slow down this march by moving faster through space, we can never come to a complete standstill, nor can we reverse our course. So, in this sense, we are all time travelers, journeying into the future at the steady pace of 1 second per second. But what about those grand dreams of zipping back to the past or catapulting into the distant future? Well, that's where things get a bit more complicated. Have you ever heard of the twin paradox? It's a thought experiment in special relativity that involves a pair of twins, one of whom makes a journey into space in a high-speed rocket and comes back home to find the other has aged more. Imagine this. One twin, let's call him Alex, stays on Earth, while his sibling Ben rockets off into space. Ben is moving at a speed close to the speed of light, and when he returns to Earth, he finds that Alex has aged significantly more than he has. This is the twin paradox, and it's a direct result of a concept known as time dilation. Time dilation is the idea that time is not absolute. It's subjective, and it varies depending on one's speed and position in the universe. When Ben moved at a speed close to the speed of light, time slowed down for him relative to his twin on Earth. This is because the faster you move through space, the slower you move through time. Now let's add another layer to this. Not only does speed affect time, but so does gravity. This is because gravity distorts space-time. The stronger the gravitational field, the slower time runs. So if Ben had ventured near a black hole, time would have slowed down even more for him. When he returned to Earth, he might find that hundreds of years have passed, while he has aged only a few years. But remember, from Ben's perspective, his clock was ticking normally. It's only when he compares his clock to Alex's that he realizes he's essentially time-traveled into the future. This concept of time dilation and the twin paradox opens up fascinating possibilities for time travel, but it's not without its downsides. After all, if you were to journey at near light speed or venture near a black hole, you'd return to an Earth far removed from the one you left behind. So, in a way, moving faster through space or being near a massive object like a black hole could make you a time traveler to the future. Black holes, these mysterious cosmic bodies, hold secrets not only about our universe, but also about time travel. Black holes, celestial phenomena that have captured the imagination of scientists and sci-fi enthusiasts alike, are regions in space where gravity is so strong that nothing, not even light, can escape their pull. But did you know that these cosmic behemoths, these seemingly insatiable devourers of galaxies, may also hold the key to our understanding of time travel? You see, black holes don't just pull in matter and light. They also distort space-time, that four-dimensional fabric of our universe. They are so massive and dense that they cause space-time to curve around them. This curve, or what we refer to as gravity, influences not just space, but also time. The closer you get to a black hole, the slower time appears to pass. Let's imagine for a moment that our twin decides to take a quick trip near the event horizon of a black hole, that point of no return beyond which everything is sucked in. As our twin ventures closer and closer to this boundary, their time would start to slow down relative to ours. For them, time would still seem to pass normally. Their watch would still tick away at the same rate. But for us, watching from a safe distance, it would appear as though our twin is frozen in time. And here's the fascinating part. When our brave twin eventually pulls away from the black hole and returns to Earth, they would find that more time has passed here than for them. They would have effectively traveled into the future. But remember, this is a one-way trip. As of our current understanding of physics, we can't reverse this process to travel back to the past. So, while it's a fascinating concept, the practicality of using black holes for time travel remains questionable. So, black holes could be our best bet for a one-way trip to the future. While the idea of time travel is tantalizing, it comes with its fair share of challenges and potential consequences. Let's delve into the practicalities. The energy requirements for time travel, as predicted by current scientific theories, are astronomical. We are talking about harnessing the energy equivalent to that of an entire star, or creating machines capable of distorting space-time. This is far beyond our current technological capabilities. Also, there's the issue of navigation. Time is not a simple straight line, but a complex four-dimensional structure. Navigating through the past, present, and future without getting lost in time would be a monumental task. Then, there are the potential paradoxes. Imagine going back in time and altering an event, a phenomenon often referred to as the grandfather paradox. If you were to say, inadvertently prevent your grandparents from meeting, you would never be born. But then, who traveled back in time to prevent their meeting? It's a mind-bending loop with no clear resolution. And let's not forget the ethical implications. Who decides what past events to change and what to leave as is? The potential to rewrite history is an enormous responsibility, fraught with moral dilemmas. Then there's the butterfly effect. The idea that even the smallest action in the past can have a massive impact on the present. A seemingly insignificant alteration could potentially result in an entirely different world than the one we know today. Finally, there's the issue of how the human body would cope with time travel. Would our bodies age differently? Could we survive the physical stress of moving through time? The challenges of time travel are considerable and the potential consequences are staggering. Yet, these difficulties serve to deepen the allure of time travel, making it a captivating subject of scientific and philosophical exploration. The mysteries of time travel continue to perplex us, painting a picture of a universe far more complex and fascinating than we could ever imagine. As we venture deeper into the realms of physics and cosmology, the boundaries of what we thought were possible continue to expand. In our journey through the mysteries of time travel, we've explored the mind-bending concepts of the twin paradox and time dilation, the gravitational pull of black holes and their influence on time, and the challenges and potential consequences of meddling with the past. We've discovered that time is not a constant, but a variable that can be manipulated under certain conditions. We've learned that moving at high speeds or venturing close to massive objects like black holes can cause time to slow down, effectively allowing us to journey into the future. Yet, this form of time travel is not without its drawbacks. As we've seen, embarking on such a voyage would mean saying goodbye to everything we know, as the world we leave behind would continue to age at its normal rate. As for traveling to the past, the jury is still out. While theories like the existence of tachyons, hypothetical particles that move faster than light, offer a glimmer of hope, they remain unproven. The risk of creating paradoxes, like the infamous grandfather paradox where one could potentially prevent their own existence, further complicates matters. Despite these challenges, our exploration of time travel has yielded profound insights into the nature of our universe. It's pushed us to question our understanding of time and space, and to grapple with concepts that defy our everyday experiences. For now, time travel remains a captivating concept, a testament to our relentless pursuit of knowledge. Who knows what the future holds? Perhaps someday we might just find ourselves stepping through the doors of time.